All right, so let's take a closer look at the queue and its implementation. We're going to look at two different implementations. One, we're going to be looking at the queue implemented with a regular list. And then we're also going to be looking at the queue implemented using a linked list. So let's begin with the list version, just because it's much more simpler. Uh, the downside of the list version is that you have a set size. So there can only be so many items in the queue. Whereas the linked list version, you can make it dynamically sized, so you can have potentially infinite elements. In reality, that's not the case, but you don't have to know ahead of time how many elements you want in your queue, and that's the benefit of the linked list version. Of the list version, you do. So let's have a little refresher on what the queue is. So basically, it's a list where the first element in is the first element out. So when you add to a queue, you add the element to the end of the queue, and when you pop from the elements from the queue, when you that's dequeuing, and you'll be popping from the head. So you'll be seeing the last element that you most recently added. So if this was a list of 2, 3, 4, 5, 6, 7, 8, dequeuing, you would pop 2 off of the list, and then that would make 3 the next item on the list. And if you're in Q9, that would go at the end of the list. So yeah, a queue is a linear data structure that is open at both ends, and the operations are performed in first in, first out order. A queue is a list in which all the additions to the list are made at one end, and all deletions from the list are made at the other end. The element which is first pushed into the order, the operation is first performed on that. We can basically think of a queue as like a line waiting list. So this can be like a line waiting to purchase tickets, where the first person in line is the first person served, i.e. first come, first served. Position of entry into queue is ready to be served. That is, the first entry that will be removed from the queue is called the front of the queue, sometimes the head of the queue. And if we look back over here, we can see that. So the front of the queue is called the front or the head, and the back of the queue is called the back or the tail. Similarly, the position of the last entry in the queue, that is the one most recently added, is called the rear or the tail of the queue. And you can only add elements in towards the back of the queue. So yeah, that's this case. If you dequeue, you pop from the front. If you in queue, you add to the end. So dequeuing changes the pointer of the front of the head, and in queuing changes the pointer of the back or the tail. So if you dequeue, you change the pointer to the next element. If you in queue, you change the back pointer to the most recently added element. So yeah, queues can be represented in arrays. In this representation, we're going to be implementing it using an array. So the queue is the name of the array storing queue elements, and the front is the index where the first element is stored in the array, representing the queue. And the rear is going to be indexed where the last element is stored in the array, representing the queue. There are multiple types of queues. There are input restricted queues, and these are queues that only take a certain type of element. It could be taken from only one end, but this can be done from any of the ends. Okay, no, I was wrong. That's not what that is. That just means that the input can be only taken from one end, but you can delete from both ends. So basically, the input is restricted, but the output isn't. Um, yeah. And we can think of the output as the deletion, or like where you pop from the queue, or where you remove elements from the queue. In the output restricted queue, uh, the input can be taken from both ends. So meaning you can add someone to the front of the line or the front of the queue, but deletion can only be done from one end. So this can be like if someone's cutting in front of the line. You can cut from the front of the line, but you can only take in customers from the front of the line. Circular queue is a special type of queue where the last position is connected back to the first position. Here, the operations are also performed in first in, first out order. There's a double-ended queue called a dequeue, which is a double-ended queue where insertion and deletion operations can both be performed from both ends. A priority queue is a special type of queue where elements are accessed based on the priority assigned to them and not necessarily the order in which they are added. This is the case of, let's say you want to have a line of customers waiting to get on an airplane, and sorry. And this is a type of priority queue where the business class customers, they go before the regular class, the coach class customers. And the luxury customers are the first class customers go before the business class customers. But the order in which these customers might buy their tickets isn't the same. So someone could, at the last moment, buy a first class ticket to Norway, and even though there are other people in front of him, because he has a first class ticket, he gets to skip the line. And the priority in which items are dequeued will be based off that priority mechanism. So to first create a queue, let's go over what the basic functions of the queue that we need. So we need an enqueue function, which adds an element to the end of the queue. We need a dequeue function, which removes the elements from the queue. So this would be removing from the front. We need a peak or the front, which gives us the data at the first node without deleting it. We need a rear function, which returns the element at the rear end without removing it. So this is the element that we most recently just added. We need an isFull function to check if the queue is full. And we need an isNull function to check if the queue is empty. Can't go to the next line. So this actually got messed up, so let's just move this. So the enqueue function, basically what you're going to be doing is you're going to check if the queue is full. If it is full, then you return an overflow error and exit, because you can't add any elements to a full queue. If it's not full, you increment the rear pointer to point to the next empty space. Then you add the data element to the queue location where the rear is pointing, and then you return success because you're done. Let's see if we can get an example. So this is an example of running the enqueue function. So let's say you have a list where this is the front and this is the back. So you'll have 40, 30, 20, 15, and 10. If you want to add 5 to this list, what you'll do is you'll move this pointer backwards to the next empty space. So this will then point to 0. And then you put the data that you're going to be adding into that empty space. And so then your queue function will look like this, where you'll have 40, 30, 20, 15, 10, and 5. And but this is before we move the pointer. So obviously the pointer will be here now. So first, we just got to check if the queue is full. So if it's full, then you got to exit out, say that the queue is full, and don't do anything. Otherwise, you insert the element at the rear pointer, and then you move the rear pointer. So insert it into empty space, then move this pointer. The dequeue function removes or accesses the first element from the queue. So this will be the front of the queue. To perform the dequeue operation, you first got to check if the queue is empty. If it's empty, then you return an underflow error and exit, because you can't pop from an empty queue. If the queue is not empty, you access the data where the front is pointing, and you then increment the front pointer to point to the next available data element, and you return success. So what that looks like, if you have a queue which is 40, 30, 20, 15, and 10, if you call dequeue, you will be returning 40, and you'll then be moving this pointer back one towards the other elements in the queue. So you return 40, and then you move this pointer inwards towards the other elements. So then after you call dequeue, front will point to 30, and 40 will no longer be in the queue. And so this is it. So first you gotta check if the queue is empty. If it is, you just gotta return queue is empty, and you check that by seeing if this pointer is equal to this pointer. So in the queue, you'll be having two pointers. You'll have a front pointer and a rear pointer. And if they ever meet together, if they're ever at the same point, then the queue is empty. And so as you pop elements from the queue, this pointer will grow closer and closer towards the rear pointer. And so when you're going to be dequeuing, what you're going to be doing is you're going to be moving all the elements from index 2 till the rear to the left by 1. So you'll be moving these elements back 1. And then you remove the rear. So you decrement the rear pointer. The front function returns the element at the front end without removing it. So this is just going to be calling the queue, and you're just going to be calling the queue at the pointer that points to the front. So it's just going to be, you're just going to be accessing the array at the index of the front. Rear is similar. You just return the element at the rear end without removing it. At the rear end without removing it. So in this function, it does it weird. It does this by popping all the elements until you're pretty much only have one element left, and then returning the last element. But there's other ways you can implement it where you just call the array at the rear pointer, and you return what the element at that point. The isEmpty function will just return whether or not it's empty or not, and you'll know this when either the front is at the same index of the rear, or if the front is at -1. You'll know the isFull operation. This will just check if the front is at 0, so meaning you've added the total elements of the array size, or if the rear is at the max size -1. So or no, this is an AND statement. So this is when it's both, with both conditions are true. When the front is at 0 and you haven't popped any elements, and also if the rear is at the max size. Otherwise, you'll know it's not full yet. And so this is what it looks like. What you're going to be doing is you'll have a class called a queue, which will have pointers. It'll have front, rear, and size. Or these aren't necessarily pointers because they're not pointing to memory, but they're pointing to indexes. Sorry if that was confusing. The front is going to point to the index, the first element added, and the rear is going to be pointing to the last element added. And the size is going to be the size of the array list that you're going to be making. And ARR is just going to be short for array, and that's going to be the integer array that you're going to be making. And so when you create a queue of a certain size, so let's say cap, you're going to create a new object. So it's going to have these values in these records. You're going to create a new record. That's going to have these values in it. You're going to assign cap, like the capacity of the queue, to the value that you're passing in from the parameter. You're going to assign the front to the size 0 to 0. So the front is going to be index 0. The rear is going to be equal to the capacity minus 1. So if you give it a queue of 5, the rear is going to be equal to 5 minus 1, so 4. And you're just going to create a new array. So this is going to queue.arr is going to be the array of the class, and you just make that by calling new int, and it's going to make a new array of size capacity. So and size of int, just make sure that the C++ allocates enough memory for an integer, but pretty much it's going to be an integer array with the size of the capacity. And at the end, you're just going to return the queue. And then it's going to have the rest of the functions that we just covered. All right. So let's take a closer look at the enqueue and the dequeue functions. So this is the function to add an item to the queue, and it changes the rear and the size. So first you're going to pass in a pointer that points to the queue class, as well as the item that you want to add. And so first we got to just check if it's full, and if it's not full, then we can proceed. But if it is full, we want to early return and not do anything. So first, you access. Sorry, one moment. Sorry, where were we? So we access the queue's rear. So remember, the queue is a class, and it's going to have some useful data properties for us. So it's going to have a. Why is this door so creaky? So, right. So remember, the queue has a class, and it's got some useful properties for us. Like it's got a index with the rear. And so first we're going to access that rear, and we're going to change it. So when we enqueue a function, we are going to change the rear to the rear plus 1. And we're going to increment it by the size of the array. This part can be confusing because this has to do with the fact that the indexes of the arrays are going to change based on the type of the array. So this just means that it's incrementing the index by 1 at the size of the queue, because remember that integers have a memory size, and so this just makes sure that when you increment it, it's going to do it properly. So then you're going to fill in that new rear that you just made. So you're going to get the array of the queue, and you are going to set the item, the queue position, the rear. You're going to set the item equal to the item that you're taking in. So at the rear position in the queue, you're going to set it equal to item, and you're going to also increment the size by 1. So you're going to get the size, and you're going to make it equal to the same size plus 1. And then you're going to print the item. So you just added that item to the queue. The dequeue function removes an item from the queue, and it will be changing the front as well as the size. So first you check if it's empty. Then you're just gonna return early. Otherwise, you're gonna access that item. So first, you're gonna create a new item that is going to be this new item that you're gonna be accessing. So you're gonna first grab the array of the queue, and remember, you're passing in the queue class, the queue pointer, the queue object that you're gonna be messing with. So you're gonna access the array, and then you're going the array of the queue that you passed in, and you're going to access it at the front position, and that will get you the item at the front. And then you're gonna change the front to be you're gonna move it forward 1 position. So you're going to change the front to be pointing at the next item that you're going to be that the second to first item in the queue. So let's go back. So that's going to be this when you move this pointer back 1. Yeah, and so these front and these rear functions are just going to be, oh, right. So you're going to move the front, and then you're going to decrement the size by 1 because you're moving an item. And at the end of it, you're just going to return the item that you just accessed. The front command, the front function, just returns the item at the front of the queue, and it does that by accessing the array from the queue class at the front index. So it accesses the front index from the queue, and it just returns that element. And similarly, the rear is the same case, but same situation, where you're going to be accessing the queue at the rear position, and then you're going to do that by accessing the rear data at in this queue class. So here's some driver code. You create a queue with a size of 1,000, and you add in 10, 20, 30, and 40. And when you call dequeue, the item that you're going to be popping out is 10, because that's the first item that you added. And at the rear end of the queue is going to be 40. In the case of a non-circular queue, you check out the queue is full before you add an element. Then you increment the rear index to point to the next available position in the queue, and you place this new element at the rear position, and you update the size of the queue. So this is kind of a more simpler version of the previous enqueue function. I believe this one, where you check if it's empty, you create an item, and you no, sorry, this is dequeue. You check if it's empty or if it's full. Otherwise, you can't add an item. You update the rear position to be the next position, the next available empty spot, and you then fill that position with the item that you're going to be adding, and then you update the size. Similarly, dequeue, same situation. You are going to make an item which is going to be the queue at the front position. So you're going to be accessing the queue's array and accessing the queue's front variable. you were going to change front to be +1, front, you're going to change the queue's front value to be front +1, and you're also going to decrement the size by 1, and then just return the element. In a linked list, a queue will have 2 pointers, a front and a rear pointer. The front points to the first item of the queue, and the rear points to the last item. And so enqueue would be adding a new node after the rear, and it moves the rear to the next node. Similarly, dequeue would be removing the front node and moving the front to the next node. So the linked list implementation of a queue involves creating a class called a queue node with the data members data and queuenode.next. So it'll be similar to where we had data and we have a pointer. And we'll have a parameterized constructor that takes in an integer value as a parameter and says data equal to x and x is null. The changing of the pointers will be done by its parent, by the queue class you're going to be creating. And so you create a class queue with data members of a queue node front and rear. And these will be the nodes of the front and the rear. And so the queue class in a linked list implementation will just be a linked list with additional pointers, one pointing to the front and one pointing to the rear. And so the enqueue operation with parameter x creates a new queue node, temporary, with data equal to x. In the case that the rear is set to null, then you set the front and the rear to temp, and you return. Otherwise, you set rear next to temp, and then move rear to temp. In the case of dequeuing, the front is set to null. This is the base case. If the front is set to null, so the queue is empty, you just return. You return early. Otherwise, you initialize a queue node with temporary with front and set front to its next. If the front is equal to null, then you will set the rear to null, and you will be deleting temp from memory. This is what the linked list implementation looks like. And okay, just seeing what I got in front of me. I'll likely be whiteboarding this out just to show that, drive the concept home. Okay, so same case. We'll be having a node. This is our queue nodes, and it's going to have a data, and it's going to have a pointer that points next, and it's going to have an integer, a constructor, where it's going to set that the data of the node equal to the data that you're passing in. And so this is what the queue class really looks like. And so pretty much you're going to have a front and a rear pointer, and so these will point to queue nodes. And initially, when you first create it, both the front and the rear are going to be equal to null. And enqueue is the act of adding a value to the queue, this linked list. So a temporary, you're first going to make a new queue node temporary. Queue node temp, and you're going to make this new node, and if the queue is empty, then this new node will be the front and the rear. So you're going to set front and rear equals to temp. Otherwise, you're going to add this node at the end of the queue, and you're going to change this rear. So you're going to access the current rear, and you're going to set its next pointer equal to temp, and then you're going to set the rear pointer equal to temp. And I'll be happy to whiteboard this out. So let's see, this is going to be, so we'll look at queue, enqueue, and then we'll look at dequeue. So we're going to whiteboard enqueue first. Okay, so this is the queue class. And as a reminder, these are what our nodes look like. They got some data, and they got a link, which is going to be a pointer. And the queue class is going to have a rear pointer and a front pointer. And initially it's going to be empty, so these pointers are going to point to nothing. And if it's empty, and we want to add some data to it, we want enqueue an item. Let's say we call it enqueue A. What that's going to do is it's going to create an item called A with it's going to create this item, and it's going to check if rear and front are null, and if they are, then we're going to move these pointers and we're going to point it to A. So A is going to be the front and the rear. And if it's empty, then we don't have to point A to anything. And if we call enqueue again, so let's say we call enqueue B, then if we were to make another node, and we'll call this one B, then it is going to add this node to the rear. So it is going to make this equal to rear. And since rear is equal to A, it's going to make it equal to A. And let's space this out so we have more space. So B is going to be equal to A. And then we update rear. So any new nodes that we add, we update rear. Let's say we want to add C. So let's enqueue C. Actually, let's go ahead and dequeue. So let's dequeue, and then that's just going to give us the item at the head. So we access the node at the front. So we look at this pointer, and we see it's A. So what we're going to do is we are going to delete this. Well, first we're going to return it. So we return this. This is what we return. And then we'll delete it. So this will get deleted, and we will change the front so that we will be moving the front pointer back one. And so front will point to B. And B will point to nothing. And so then let's also enqueue C. And so that would be like this. And same deal, where we are going to create this variable. We are going to link it by accessing rear and pointing it to B. And boom. And then we update rear. So instead of pointing to B, it will now point to C. And now we will go back to the slides. So we can see that here at temp, we create a new linked list node. Actually, I just went over this. So adds a new node at the end of the queue and changes rear. So we make rear.next equal to temp. Yeah. And then we make it to temp. For dequeue, if the queue is empty, we return null. Otherwise, we store the previous front and move front one node ahead. If front becomes null, then we change rear also as null. And then we delete temp. Yeah. Yep. And I believe that's it. Thank you for watching. This is a driver of the queue list, and I'm not going to go over it, but that's it. Thank you for watching.